So moving on to the back side of the first page is page number 2. Number 10 says graph the inequality. So graphing an inequality is almost exactly the same as graphing an equation. The only difference is you still need to get it in slope-intercept form. The only difference is that you need to decide if it's a solid line or a dotted line. And then on top of that, you need to decide what side to shade, one side or the other of the line. So as you can see, this is in slope-intercept form, so you don't have to even modify the equation. You already can see that the m value is -3/1, and you could already see that the b value is +2. So it crosses the y-axis at 2, and from that point, I'm going to go down 3/1 because my slope is down 3/1. So down 3, 1, 2, 3/1. I'm going to put a dot right here. And that is your line. Now you could continue to go down 1, 2, 3/1 and put a dot right here. And you could even go backwards if you'd like, but it's going to be off the line anyway. So the question now is, do I draw my line as a dotted line going through these dots or a solid line going through these dots? Solid. Definitely solid. Thank you very much. So I'm going to draw a solid line right through there. And now we need to shade in either one side of the line or the other. So what I like to do is, if possible, I like to test the point 0, 0. 0 for x, 0 for y, which is clearly on the bottom left side of this solid red line. So if you test 0, 0 and it works, that means that this point right here is a solution. That means that all the solutions on this side would be true. All the answers are on this side. If I test 0, 0 and it doesn't work, that means it's not a solution. That means that the solutions are on the other side. So how do you test 0, 0? You simply plug it in and see if it works. Let's plug it into the original. You see how it says y is greater than or equal to? I want to say 0 is greater than or equal to. And then it says -3 times x. I want to say -3 times 0 and then +2 at the very end. So if I plug in 0 for x and 0 for y, it's going to say 0 is greater than or equal to +2. Is 0 greater than +2? Is 0 greater than +2? No, 0 is less than 2. So this does not work. So I cross it out. What does that mean? That means that my answers are on the other side of this line. So I need to shade in the other side of this line. So this is another question on the test. Let's move on to number 11. Right here it says write an equation in function notation. A lot of people get thrown off with those words, function notation. First of all, could you write an equation, just any equation in slope-intercept form, y equals mx plus b? Yeah. Now, they do give you a point, x and y, which is right here, and they also give you a slope. So one option is to write it in point-slope form. However, you could clearly see the b value, right? You could clearly see the b value. The b value is what? 1. The b value is 1. It crosses the y-axis at 1. So if you know your m value, which is -3, and you know your b value, which is 1, you could actually write your equation in y equals mx plus b. Right? So what is this equation in y equals mx plus b form? What is it? Y equals -3x plus 1. That's your equation in slope-intercept form. Now, when you look at your multiple choice answers, you're not going to see y equals because it says in function notation f of x. Now, f of x is the same thing as y, so the only difference is this. This is what you're going to see on the answers. F of x equals -3x plus 1. Same exact thing, but it's just in function notation. Instead of y, they write it as f of x. You get it? Let's move on. Number 12, state the domain and the range. We need to know these things. From a long time ago, it's super easy questions. You just need to refresh your memory. Remember, the domain values are your inputs, which are your x values. Okay? Now, when you talk about the range values, those are your outputs, which are your y values. Okay, so when we say state the domain, so you're going to write D, and you could put the x values being, and what are the x values of these coordinates, right? So you could actually go through the coordinates and write down the coordinates for each one of them. This one is -4, comma, -2. This one right here is -1, comma, +1. This one right here is -0.5, comma, 2. And this one right here is 1, comma, 2. This one right here is 2, comma, 1. And this one over here is 1, 2, 3, 3, comma, -1. So when we're talking about the x values, we're talking about this -4, this -1, this -0.5, this -1 right here, and this 2 and 3. So what are all the x values? We're going to go with -4. We're going to go with -1, -0.5. I need more space. Let me erase this. Let me do -0.5. That looks better. -0.5. And also +1, +2, and +3. So 1, 2, 3. Those are all the x values of the coordinates that we see right there. And now let's list all the range values, which are all the y values of the coordinates that we have on the graph. So here's one y value, -2. Here's another y value, which is 1. Here's another y value, which is +2. Here's another y value, +2. Since you already wrote it, you don't have to write it twice. Here's another one that's at +1, which is already there. And here's another one that's at -1, so you'd write that one also, -1. They probably are going to put the list in order from least to greatest. But anyways, that's how you answer for domain and range. It's really no math involved. It's just knowing that the domain are your x values and the range are your y values. Moving on to number 13 and 14, it says determine if the following equation is linear. Once again, linear equations cannot have letters that are squared. Can't have x squared, cannot have y squared, or y to the third, or x to the third. You cannot have a fraction with x in the denominator. So for example, if I would have said y equals 3 divided by x, that would no longer be a linear equation. It'd be some other type of curve. Okay? But obviously that doesn't happen on 13 or 14. And you could also not have two variables multiplied together. So right here you have x times y. That means that 13 is not linear. So let me erase this example I wrote. So 13 is not linear. Why? Because it has an x times y in it. So number 13, not linear. Okay? It says determine if the following equation is linear. So number 13 is not linear. It says if yes, then rewrite it in standard form and then determine the x and the y intercepts. So moving on to number 14, this one is linear and they want us to rewrite it in standard form, but guess what? It's already in standard form. ax plus by equals c. So now they want us to find the x and the y intercepts. So once again, to find the x-intercept, we must set y equal to 0. To find the y-intercept, we must set x equal to 0. So let me write that down. So that's what we need to know. To find the x-intercept, set y equal to 0. So let me use this same exact equation, but instead of y, I'm going to put 0. Instead of this y, I'm going to put 0. So I'm going to have 3x minus 4 times y, but instead of y, we put 0, equals -12. So obviously -4 times 0 is nothing. We really have 3x equals -12, which means that when we divide by 3 and divide by 3, our x-intercept is -4. And for the y-intercept, we're going to rewrite the same exact equation, but we're going to set x equal to 0. So instead of 3x, I want to put 3 times 0. Check it out. 3 times 0 minus 4y equals -12. Let me put that 0 in there. And of course, 3 times 0 disappears because it's nothing. We have the new equation, -4y equals -12. So you divide by -4, and you divide by -4, so your y-intercept is +3. So for this question number 14, we say yes, it's linear. we say it is in standard form. Now, if for some reason the y was here and the x was over here, we'd have to switch them, right? But it already is in standard form. And then after that, we have to find the x-intercept and the y-intercept. The x-intercept is -4 on the x-axis. The y-intercept is 3 on the y-axis. Let's move on to 15. Way up here, sorry. It says, write the slope-intercept form of an equation that passes through the given points and is perpendicular to the graph of the equation. So they want us to write a slope-intercept form equation. Okay, that really is a y equals mx plus b. So they want us to write an equation that looks like this. Y equals mx plus b. But how are we going to write this equation? They tell us that it passes through a certain point. And the point they give us is the coordinate -4 and -5. And then they tell us something else. They tell us that our line is going to be perpendicular to the line that they give us right here. Now, perpendicular means negative or opposite reciprocal slopes. So what does that mean? That you could see their equation and you could see that the slope is what? -2. And what you want to do is get your own slope out of there. You want to get your own m value out of there by taking that slope of -2 and making it an opposite reciprocal slope. So what does opposite reciprocal mean? You're going to change the sign and you're going to flip the fraction. And if you're thinking, well, that's not a fraction, okay, make it look like a fraction. Put it over 1. And now go ahead and change the sign and flip the fraction. What do we get when we change the sign and flip the fraction? Positive 1 over 2. So that is the slope of our line. So guess what? We don't need this equation anymore. I'm never going to look at that equation again. The only thing that I got out of there was my perpendicular slope, which was an opposite reciprocal of the slope that that equation had. So now there's two ways of solving this problem. I do have a slope, I do have a point. So I could go for point slope form, which is y minus y1 equals m parenthesis x minus x1. Or I could just stick with slope-intercept form y equals mx plus b. But in order for me to just use y equals mx plus b, I have an m. I still need to find a b value. So I could plug in what I have, my m, my x, and my y. I could plug all these three values into y equals mx plus b so I could solve for b. Then once I have my b, then I can write my equation in slope-intercept form. So it's totally up to you guys. Because this is a review video, I want to explain both ways of doing it. I'm going to first do my point slope form. So I could see my point right here. So the -4 is going to go right here where the x is at. My -5 is going to go out here where the y, or right here where the y is at. And my m value of 1/2 is going to go right here. So let me rewrite this point slope form equation with blank spots. And once again, let's plug in our x value of -4 right here. So -4 goes right in there. My y1 value is -5. My m value is 1/2. So there's my point slope form equation. Change the minuses to plus. And now all you have to do is change the way it looks to get y by itself and to get rid of the parentheses. So the way to do that would be to distribute the 1/2. 1/2 times x, that's 1/2 x. 1/2 times 4. If you put the 4 over 1, that'd be 4/2. 4 divided by 2 is +2. Of course, bring down the equal sign, bring down the y and the +5. So all I need to do now is get rid of that +5 by doing the opposite, -5 and -5. So my final slope-intercept form equation is y equals 1/2 x minus 3. There is my slope-intercept form equation. Y equals 1/2 x minus 3. And that's my answer. Now let's say you're not comfortable with the point slope form. Let's say that once you got your perpendicular slope from this original equation and you wanted to use the slope that you got and the x and y values, and you only wanted to use your y equals mx plus b form, we could do that. So here's an alternate method. So we have y equals mx plus b. What I'm going to do is take the x value of -4 and put it right here. I want to take the y value of -5, put it right here. And then I'll take my m value of half and put it right here. Check it out. So I plugged in my x value right here, my y value right here, and my m value right there. Now all I need to do is solve for b. So if I did focus in on the right side, I have 1/2 times -4. Half of -4 is simply -2. Or you could think of it this way. 1 times -4, that's -4. 2 times 1, that's 2. And -4 divided by 2 is -2. Bring down the plus b, bring down the equal sign, bring down the -5. And you almost have b by itself. All you have to do now is add 2 and add 2, and you'll get the -3 equaling b. So b equals -3. So what we found was the b value of -3. So now that you know the m that we found by getting the perpendicular slope of the original equation they gave us, and now that we found the b by plugging in x, y, and m into y equals mx plus b and solving for b, now I could actually write my equation in y equals mx plus b form, which would be y equals 1/2 x minus 3, and that's exactly what it says down here. So these are two totally different ways of getting the same slope-intercept form equation when they give you a point and a line that's perpendicular to the line that you want to get. So let's move on to number 16. Write the equation in slope-intercept form. That one's easy. All you have to do is change the way it looks. So you want y by itself and you don't want those parentheses. What would be the first thing that you do? Distribute the negative, right? So that's going to be a -x. That's going to be a +7. Bring down the equal, the y, and the +4. One more step to get y by itself. Subtract 4. Subtract 4. Of course, numbers with numbers. Y equals -x plus 3. Ladies and gentlemen, we're done. That's your slope-intercept form equation. That was easy. Number 17. Write the point-slope form of an equation that passes through the point with the given slope. Okay, so this is pretty straight up as well. You could say this is a point and this is a slope, which means I could use point-slope form. Or you could just plug it all into y equals mx plus b to solve for b. So since we did point slope just a little while ago, let's just use y equals mx plus b first to get our answer. So let's plug in the y value is -9, so let's plug in -9 for y, equals the m value, which is -7, times x, the x value is 5 on our coordinate, and then plus b at the very end. So we really have the equation -9 equals -35 plus b. To get rid of the -35, you go plus 35 and plus 35. So we're going to end up with 26 as the b value. So ladies and gentlemen, once we have the b value and we already had the m value, now we could write it in slope-intercept form. Wait a minute, they're not asking for slope-intercept form. Whoops. So this was kind of a waste. I already know my equation is y equals -7x plus 26. But that's my slope-intercept form, and it clearly says right here, write the point-slope form. So we do want this form right here. So let's start by writing the blank spots. And inside those values, we're going to put the y1 value, which is -9, the m value, which they gave us was -7, and the x1 value, which is 5. And all you have to do is change the minus to plus, and there's our point-slope form equation. Y plus 9 equals -7 parentheses x minus 5. Do not distribute. We actually want that form, point-slope form. Should have read the instructions carefully, I'm sorry. So this was kind of a waste of time. Even though it really is the same equation, this one's in point-slope form, and that's what they want, point-slope form. Number 18. It's the last one on this page. Solve the proportion. So you could think of it as an equation that has fractions, and you could get rid of fractions by multiplying both sides by the denominator. Or you could think of this as a proportion, and when you have a proportion, one fraction equaling another fraction, you can cross multiply. So if you do cross multiply, that's right. You're going to have 1 times 3h, that's 1 times 3h equals 6 times 5, equals 6 times 5. So 1 times 3h really is 3h. 6 times 5 really is 30. All you have to do is solve that by dividing by 3, and you get h equals 10. That's your answer. H equals 10.